All right, welcome. Today we are diving into what is, hands down, one of the greatest scientific detective stories ever told. Seriously, it's a mystery that took decades to crack, with clues scattered across entire continents, buried deep under the oceans, and hidden in the very heart of our planet. So let me just ask you this. What if the solid ground you're on right now isn't so solid? What if the continents themselves are actually drifting across the globe? It sounds like pure science fiction, right? Well, that single, wild question is exactly where our story begins. Our investigation starts way back in 1912, and it doesn't begin in some fancy lab, but with a simple map and a guy with a really good eye who just stumbled upon a clue of planetary proportions. Okay, so our first detective is a German meteorologist named Alfred Wegener, and he's just looking at a world map when he notices something that once you see it, you can't unsee it. The coastline of South America and the coastline of Africa, they look like they could just slot together almost perfectly. It's a jigsaw puzzle on a global scale. This aha moment led Wegener to propose a truly radical idea he called continental drift. He imagined a time deep in the past when all the continents were squished together into one giant supercontinent. He called it Pangaea, which means all lands, and said it was surrounded by a single massive ocean he named Panthalassa. But Wegener knew the jigsaw fit alone wasn't going to cut it. He needed more proof. So he started digging. And wow, did he find it. He found rock formations of the exact same age and type on opposite sides of the Atlantic. He found fossils of the same little land-based reptiles on continents now separated by thousands of miles of water. He even found evidence of ancient glaciers in places that are now scorching hot tropics. It was just a mountain of compelling evidence. Wegener had laid out this brilliant case for what was happening. The continents were moving, for sure, but his whole theory had a fatal flaw. A huge, gaping hole that got his idea pretty much laughed out of the room for decades. He couldn't answer the single most important question. What kind of force could possibly be strong enough to shove something the size of North America through the solid rock of the ocean floor? Wegener had some ideas, like the spin of the Earth or the pull of the tides, but scientists did the math and said, nope, not even close. Way too weak. So his theory, despite all that evidence, was basically dead in the water. And for almost 50 years, the case went totally cold. But then, new technology from World War II opened up a whole new frontier for science, the deep ocean floor. And what we found down there in the dark, well, it changed everything. All of a sudden, we could map the bottom of the ocean, and these maps revealed something nobody expected. A single, massive underwater mountain range that snaked its way all around the globe for 65,000 kilometers. It dwarfed anything on land. They called it the Mid-Ocean Ridge, and it looked like a giant seam stitching the planet together. A geologist named Harry Hess looked at this and had a stroke of genius. He said, what if this ridge is where new ocean floor is literally being born? He pictured magma bubbling up from inside the Earth, hardening into new rock, and pushing the older seafloor away to either side, just like a giant conveyor belt. And the proof was just beautiful. When scientists actually tested the rocks, they found the youngest ones were right at the center of the ridge, and they got older and older the farther out you went. Even cooler, they found these magnetic stripes in the rock that showed Earth's magnetic pole flipping back and forth over millions of years, a perfect recording. So get this, Wegener's continents weren't plowing through the ocean floor. The seafloor itself was moving, carrying the continents along with it. Okay, so now we have the mechanism, this seafloor spreading conveyor belt. But the case isn't closed yet. We still need a motive. What's the engine driving this whole planet-sized system? Turns out the answer was even deeper inside the Earth. Decades earlier, a scientist named Arthur Holmes had actually guessed at the answer. He theorized that the incredible heat boiling up from the Earth's core could be creating these massive, slow-motion, churning currents in the semi-molten rock of the mantle, the layer right beneath the crust. The best way to picture it is like a huge pot of thick soup simmering on a stove. The hot stuff at the bottom rises up, spreads out across the top, and as it cools, it sinks back down, only to get heated up and rise again. This exact cycle happening on an unimaginable scale over millions of years was the engine. This was the colossal force that Wegener had been searching for. And just like that, all the pieces were finally on the table. We had Wegener's drifting continents, we had a spreading seafloor, and now we had a powerful engine driving the whole thing. It was time to put the puzzle together once and for all. So, in the 1960s, scientists like Mackenzie and Parker finally assembled the final theory, plate tectonics. The idea is that the Earth's rigid outer shell isn't one solid piece. It's actually broken up into a bunch of huge interlocking slabs, or plates. Probably the easiest way to think about it is to imagine the Earth is like a hard-boiled egg. Its surface isn't a smooth, perfect shell. It's a shell that's been cracked into several big pieces. Those pieces are the tectonic plates, and they're constantly shifting around, bumping and grinding against each other. And here's the kicker. It's what happens at the edges of these plates that explains almost all of the Earth's big geologic events. Where plates pull apart, you get new crust. Where they smash together, you get massive mountains and volcanoes. And where they slide past each other, you get devastating earthquakes. It all clicks into place. So solving this puzzle wasn't just about figuring out a bit of ancient history. It completely rewrote our understanding of the planet we live on. And you know what? The story is still unfolding every single day. So, how fast is all this happening? Well, on average, the plates are moving at about the same speed that your fingernails grow. Yeah, it's incredibly slow, but over millions and millions of years, that slow dance completely reshakes the face of our world. What this all means, really, is that plate tectonics is the master key for geology. It's the unifying theory that explains everything. Why earthquakes strike where they do, how incredible mountains like the Himalayas are built, why the world map looks the way it does. It showed us that our planet isn't just a static rock in space. It's a dynamic, living, breathing world. Which leaves us with one last mind-bending thought. This process never stops. The ground beneath our feet is moving right now. So what's next? What will the Earth look like in 100 million years? What new oceans will be born? What new supercontinent might form? The detective story might be solved, but the planet's story?